Hi, everyone, and welcome to another installment of Academic Insights, where we look at the ARK Invest big ideas. For today's discussion, we have Medha Parlikar from CasperLabs, where we're going to talk about public blockchains, but we're going to talk about hybrid blockchains. So, Medha, can you introduce yourself and let everyone know what you do?
Yeah, of course, Justin. Thanks so much for having me on the show today. I'm Medha Parlikar. I'm the Chief Technology Officer and one of the co-founders of CasperLabs. And CasperLabs is a professional software services company that helps enterprises adopt blockchain technology. And one of the first products we built is the public Casper protocol and the underlying Casper technology that bootstraps this public protocol.
Excellent. So all right, full disclosure. This is so that whole professional services software company within the blockchain, that's what kind of got my attention, in terms of Casper, and what made me kind of do some more research. Can you expand on that? Because that's a big gap, and you were one of the first people to actually highlight that, in one of your interviews you did, or presentations that you did.
Yeah, absolutely. So when my co-founders and I co-founded CasperLabs, we went in with the explicit purpose of building a company like Red Hat, where there's an open source software component to what we're supporting, but we help the enterprise learn, adopt, and implement and maintain and manage this technology within their enterprise deployments. And we felt that upon looking at the public blockchain landscape, one, there wasn't a protocol purpose-built for enterprise, number one. And number two, there wasn't a corresponding software technology company that was really focused on enterprises adopting this, right? All in terms of structure, in terms of product, and in terms of capabilities to provide professional services. Excellent. And so we built it.
Nice, yeah. And I look forward to seeing what that entails, because that's a big, like I said, it's a big gap within this space, and I always say that I'm the bridge in between, blockchain and, the Web3 world of blockchain and the Web2 world, of industry, especially with ERP providers. So, that's one thing that a lot of those providers are trying to figure out. They're trying to educate themselves on the space as well. So, can you talk a little bit about, this hybrid blockchain model that Casper provides?
Yeah, definitely. So we believe enterprises will use private blockchains, right? And when we talk about that, there's specific reasons why they will want to use private blockchains. They'll want to keep a significant amount of data private away from competitors, or for security reasons, or compliance and regulatory reasons. But at the same time, they do need to have guarantees that these private blockchains haven't been tampered with, right? Because programmatically, once you control all the participants or all the participating nodes in a blockchain, you effectively control the blockchain, and you can basically write whatever you want to the blockchain. Now, when you implement models that, a hybrid system, when we talk about a hybrid system, you're basically dipping your toe into the Casper mainnet, and you're providing anonymized data to that public protocol that proves you didn't tamper with the private blockchain. And those public proofs are verifiable and observable on the public mainnet. And we provide a very easy auditing interface in our product offerings and our platform offerings that allows you to show your stakeholders that, look, this blockchain hasn't been tampered with. Here are all the proofs on the Casper mainnet, which we don't control. Right. And that's a really fantastic middle ground. And we've observed that enterprises, when they implemented cloud, they implemented it in a hybrid way as part of their, march towards public cloud infrastructure. Right. And so we believe hybrid blockchains are absolutely going to be here to stay. There's a real solid set of uses where it makes a lot of sense to use private blockchains that are secured and backed by a public network.
Thank you for that. So I know that, especially over the last couple of months, zero knowledge proofs have been a popular topic. You can say that they've been, I mean, with ZK Sync coming on, they're introduced their mainnet. You have Polygon with their zero knowledge proof, offering that just came out a couple of weeks ago. So what's your thoughts on zero knowledge proofs when it comes to enterprises and adoption?
Definitely. So we also are doing extensive zero knowledge research at the Casper Association. We've got a team of folks that are looking at a ZK VM or an augmentation to the Casper VM and the Casper ecosystem to support native ZK capability. So that is something that is definitely at the forefront of our minds. I believe that for ZKs to be really ubiquitous at scale, there's still a significant amount of research and development and work that needs to be done to really bring them to the mainstream. I think they're extremely interesting, particularly in the areas of identity, anonymizing data, and providing those kinds of guarantees and proofs to end users, right? And a ZK proof basically allows you to provide a yes or no answer without revealing the source of that information. So for folks that don't understand what zero knowledge proofs are, imagine you want to get into a bar and you have to show your driver's license to the bar, to the bouncer, when all he really needs to know is if you're over 21, right? He needs proof that it is in fact me, right? So canonical proof that, yep, this is my identity. You can see my face. But you don't need my address or my date of birth or I don't need to reveal any of that sensitive information. You just need an answer like, is this person over the age of 21? And if the answer is yes or no, that's all you need to know, right? Same things with credit scores and the like, right? Like shouldn't have to give you my social security number in order for you to get my credit score. And so there's multitude of applications for ZK proofs, but I feel the technology is still very, very nascent. And over time, with improvements in silicon, with improvements in throughput and processing power, that these will become ubiquitous.
Okay. So another question that I often get, actually in the public sector. So I actually did a presentation at the Wilson Center down in DC, and one of the questions that came up is, what's your thoughts on the threat to quantum computing? In blockchain, because that's one thing that's coming up. We have some blockchains that they're referring to themselves as, quantum resistant, blockchains and things like that. There are protocols that are offering research on quantum resistant blockchains. So what's your thoughts, and what is Casper doing, to kind of create this quantum resistant, quantum proof type, world as we continue to move and as countries continue to make investments in quantum computing?
Yeah, so it's kind of funny with the quantum computing paradigm and what people talk about it in the framing of blockchain. If we start seeing quantum computing really go mainstream, we're going to have massive problems across the security stack of every communication protocol out there. So I feel like what is much, much more critical beyond blockchains is actually going to be just good old-fashioned SSH, TCP/IP, and the backbone of the internet, right? That's like, I feel like energy needs to be spent there first on like, hey, what happens to TCP/IP protocol? What happens to SSH? Because the SSH protocol and the HTTPS protocol are the ones that are going to be really at risk with quantum, right? And so if you think about all the secure transactions that happen right now, all the credit card transactions happen all right now, everything on e-commerce, those are all going to be vulnerable, right? So first and foremost, what are we going to do about HTTPS and SSH? Like those are some big, because those bootstrap everything, right? And then the layer on top of that are the blockchain protocols, right? So blockchain protocols communicate over HTTPS. Getting access to all the blockchain nodes, if you're managing any of your blockchain nodes in the cloud, you do that over SSH. So the first thing is we have to secure HTTPS. we have to secure SSH and make those quantum resistant. Then when you get to that layer, then you start talking about, okay, what are the vulnerabilities in the blockchain? And I see two big vulnerabilities. I see the hashing functions being vulnerable to quantum computing, because now suddenly you've got a computer that can, hash like crazy, right? So definitely, I'm sure the Bitcoin Core developers are thinking about like what kind of changes need to happen to quantum resistant proof of work, right? So that's the first thing. And same thing with the Casper protocol. We have a very basic hashing function that is just used, the Blake 2B hash would need to be uplifted to make that quantum resistant. And that really, that's basically like the number one thing that Casper would need to worry about is that, and then leader selection for proof of stake. We would need to make sure that that leader selection algorithm becomes quantum resistant, so you can't, discern who the leader is in consensus, for the block proposer. And from an account perspective, I think the real rub comes into accounts. So if you think about all of the accounts that exist on these blockchains, right? This notion of Satoshi's account, it's there. It's kind of there, and then how do you change that account? Right? Like, what do you do with those accounts? Because those are public-private asymmetric key pairs, and those are not quantum-resistant cryptography. So how do you take Satoshi's account and you make Satoshi's account quantum-resistant? That's a real hard, that's a very difficult problem. And the only way to fix that, like, how do you even fix that? Right? Each individual would have to basically migrate their account to a new quantum-resistant standard. But even then, the Bitcoin blockchain or even the Ethereum blockchain or any other blockchain out there doesn't really support strong account recovery models, right? And so the Casper protocol has a very strong account recovery model. I can associate new keys with my account and I can brick old keys. So for the Casper protocol, you could basically just, create a client-side quantum resistant key, and through a very simple transaction, associate that quantum resistant key with your account, and you can brick the old key. And so on Casper, there is a very clear path forward for our community to basically make all the accounts quantum resistant, right? So I believe all the blockchains would have to do serious and big protocol upgrades to support hashing that's quantum resistant and leader selection that's quantum resistant. But then the account problem remains a very real problem, where they would need to perform a very significant migration of all their accounts. And I wouldn't even know how they would have to begin. It'd be a very significant change for them. For Casper, I feel it would be very, very straightforward, right? Casper supports multiple key types. We already support multiple encryption schemes. We support Ethereum type keys as well as ED25519 keys. So SecP256K1 and ED25519. And then we could just add a third type. And we built it this way because we wanted to support cross-chain use cases with a single key. So you can transact on Ethereum and Casper using a single key. You can use Ethereum keys to do that. And we did that from the UX perspective, but also it makes us very quantum resistant on the account side.
Yeah, and that was you took my next question, but so so the question I had is, with your your user account structure, your user account standard, if you will, could Casper be that quantum resistant user account standard across all blockchains? So Casper is kind of kicking off that interoperability, if you will. My question makes sense. It makes sense in my head.
Yeah, it's interesting because Casper has a very rich account model. We're actually seeing in the broader ecosystem companies that want to use Casper's account model to even custody Bitcoin and Ethereum, because Bitcoin and Ethereum, they don't have a strong cold storage story, right? Where, these cold storage providers, what they do is they have a multi-signature model on each account. And Casper has a very natural capability here where you can take one key and you put it in cold storage. And now that account, you can't transact without that cold key, right? And so you need 2, 3, you could do 2, 3, 4, 5 people, up to 100 people in mainnet to sign a transaction on Casper. And so what people are wanting to actually do is build secure bridges to even support Ethereum and Bitcoin custody or any other kind of custody solution using Casper accounts, right? So basically you lock the Bitcoin into a bridge address, into a bridge contract, and then you bridge that over into wrapped Casper, and then you lock it with Casper accounts and put those keys in cold storage. And so it's a really interesting model, both from a key recovery perspective and from a multi-signature cold storage perspective. And the reason we built that account model is because if you look at any enterprise application, the one thing you're going to notice is they have a very complex user management scheme and permissioning and group scheme, right? The enterprise has very complicated authorization and governance models that they use for all their applications. And from my perspective, you want to track that on the blockchain, not in a smart contract, but you want those authorization levels enforced by the protocol, right? And so those things that are enforced by the protocol, you can't work around them in your smart contract, right? And smart contracts are really the Wild West. You can build anything you want in a Turing complete blockchain system. But if you enforce it on the protocol will say, no, you can't execute this transaction until everybody that's authorized on this account meets the requisite weight in order to sign a transaction for this account. And that's a really, really important capability that has to be enforced on the host, separate from the smart contract.
Yeah, I love that. I love that. So whenever we're talking about, so we just completed a study for the Web3 Foundation on digital inheritance, and similar to, so whenever you talk about the account recovery model, in that research we work with a lot of estate attorneys, where they're saying that a lot of their clients, if you will, they're asking about finding a way to transfer their digital assets. Not talking about, yes, crypto, yes, NFTs, but also, videos from YouTube they can monetize off of and things like that. So do you all have, or is there something on the roadmap where you can kind of create like a digital inheritance type model with this account recovery? Because that's how we're doing it. That's how we propose to do it within the Web3, within, the Polkadot and Kusama ecosystems. But I'm just using examples here. But is there something that is on the roadmap, or is that something that individuals can set up, where they can set up guardians? So with this account recovery model, can they set up guardians, where they can, say, okay, I want this to be sit here if I pass away, sit here if I pass away. Does that make sense?
It absolutely makes sense. And yes, you can absolutely do that on the Casper protocol. And the way it works in the account model is you have two types of permissions in a Casper account. You have transaction signing and you have key management. And so the way you would do this is you would designate a trustee, and the only authorization they have is key management. They're not allowed to sign any transactions per se, if that's the way you want it. So let's say you're the executor of your estate, right, would have key management authorization on your account. So upon your passing, what they would do is they would authorize the keys of the people that are inheriting those assets. And then basically they would associate that key with that account. And now that key would be able to assume a custody of the account. And the beautiful thing about this is you don't share private keys. You don't share private keys. There's no private key sharing going on whatsoever, right? So you look at companies, and there's companies that are in the ecosystem that have raised, tens of millions of dollars to do this thing called social key recovery. Well, in social key recovery, you share private keys. You share private keys with your friends and say, okay, I'm going to share my keys with these 5 other people. And then when I ask them for it, they're going to give me my private key back. But you're sharing your private keys. Now, they may be obfuscating those private keys or whatever, but fundamentally, you're sharing private keys. In Casper, you can build a social key recovery mechanism without sharing any private keys. You can just associate 5 other accounts to your wallet, and you can set your transaction weight to 5. So the only way, from a key management perspective, the only way they can associate a new key is if all 5 people sign. Or you could say if any one of them sign, right? So they would just sign a transaction to associate a new key so I can recover my account. So you can build basically any kind of permissioning scheme you want with Casper accounts between key management and transaction thresholds.
I love that. I love that. So seems like you already have the all in one solution. So is there any other features or anything on the roadmap that that you want to, let the viewers know about?
Yeah. So like,
about?
yeah, there's some really cool stuff that we're planning for 2023, and I think it's going to be really revolutionary. So one of the things that I think is a real problem for broad-based adoption of blockchain technology is the workflow it takes for a user to interact with blockchain, right? So if you want to send an Ethereum transaction today, you have to acquire Ether via an exchange. And so now you're throwing the user into that entire rabbit hole of acquiring Ether, transferring it from the exchange into a MetaMask address, creating the MetaMask address, custodying those keys, using cold storage if they want to use cold storage before they can do anything with the Ethereum blockchain in a self-sovereign way, right? And so one of the things I observed in this workflow very early on is, one, it's very burdensome for users to deal with it. And two, it's really a problem for enterprises because enterprises are not going to want users to jump through those hoops. Enterprises want this all to melt away. Right? They want to streamline the user experience for the users. But by the same token, you really want guarantees that I signed a transaction. I signed that transaction, right? You don't really want to do the same thing that's already been done in Web 2, where my credentials are stored by the enterprise and they just marshal those transactions via their centralized system. That's not really an improvement, right? Because somebody can fudge my signature if they have access to that backend database. And so really what you want is you want transactions or contracts that pay for their own execution, right? So as an enterprise, I have a smart contract, you're a user, you have a subscription service with me, and you're paying to use that system, right? And you as a user sign a transaction. I can see that you signed this transaction, but the payment for that transaction is paid for by the contract. And so really what happens is that contract is part of my subscription model. I'm signing transactions on it, but the payment doesn't come out of my wallet. I don't have to acquire any crypto token in order to do this, right? I can sign the transaction and I'm authorized to sign the transaction in that contract by virtue of the fact that I'm a customer of that contract. And so this is a capability we will be bringing in Casper 2.0. It is absolutely groundbreaking. The reason we can do that is because we have built our own virtual machine technology. It took us a long time to build this virtual machine technology based on, WebAssembly. And it's also because of what the account and contract model is on Casper and how that works, that we can do this and really streamline the user experience for enterprises and end users, right? In a very self-sovereign way. So enterprises can still get the guarantees that, no, you actually signed this transaction. And that is really, really important in business today, right? I sign for a FedEx envelope. I sign my checks when I go to, a restaurant, right? I sign for things and I get a receipt like certified email. All of these workflows are possible and enforced by the Casper protocol on the host. And you can get provable guarantees from the system that, yes, this user signed this transaction, they accepted this NFT. You can do secure transactions this way and know that the Casper protocol is enforcing it host side.
Mm-hmm. Excellent. I love that. I'm excited about Casper 2.0 myself. So thank you, Medha. Thank you for taking the time to speak to me. Where can people find you? Where can people learn more about Casper?
Yeah, you can learn more about us at CasperLabs.io. Check us out on the web. You can find me on Twitter at mparlikar. And yeah, we are at a lot of conferences. We are very much in the crypto space. And we have a Discord channel and Telegram channel. And you can learn all about that at casper.network or CasperLabs.io. Thanks so much.
All right. So thank you for that once again. And for everyone else, until next time.